So now that we've discussed the basics of equilibria, let's look at some specific examples that we'll be talking about in this class. The first one we'll consider is the solubility product. And this is the equilibrium associated with dissolving a salt in water. You can have solubility products in other things, but we will be talking about aqueous solutions in this class. You could also do this in organic solvents and things like that. We write this equilibrium constant, we give it its own special name, KSP, SP standing for solubility product. And just as an example of how we would write this, we always write the solid on the left-hand side as the reactant. So let's look at, say, this ion, mercury 1 chloride. So that's a solid, and we need to indicate that. And that will be an equilibrium dissociating into its constituent ions in solution. So this mercury 1 ion, which is a dimer, it's two mercury atoms together, but their overall oxidation number is 1, even though there are two of them. And that'll be aqueous plus 2 chloride ions that will come off of that salt as well. And so this is our equilibrium that we're considering for a solubility product. Now we can write K for this reaction. We write KSP. We take our products. Our products are our mercury 1 ion. There's only one of those, stoichiometric. And chloride, on the other hand, has a stoichiometric coefficient of 2, so we need to put the squared there. And then we divide it by our Hg2Cl2. Now this is a pure solid, so this, as we remember, goes to 1, and so our solubility product only has the ions present in it. So it'll just be these concentrations of our ions multiplied together with the appropriate exponents for the stoichiometric ratios. And this particular solubility product is 1.2 times 10 to the minus 18. Now this is much, much less than 1. What that tells us is that primarily the salt will stay as the solid. The reactants in this case are favored because we have a very small equilibrium constant that is shifted very far to the left. So we're not going to get very high concentrations of our mercury or our chloride in solution. But they're not zero. And this lets us find the concentrations of those ions. And also the other way around, if we have the ions in solution, whether they'll form a precipitate, whether they'll form a solid. And so that's why this is an important and well-studied type of equilibrium.